Hello, my name is Madeline Baird, and I'm a student at the Ocean Research College Academy through Everett Community College. And today I will be talking about harbor seals and their behavior in the Snohomish River. Harbor seals are the most common pinniped in the Pacific Northwest. They haul out of the water to rest, avoid predators, for molting, pupping, nursing, and social interaction. In previous studies done in the Washington State region, tidal state has been found to influence availability or suitability of haul-out locations. A study in Head Canal found that the highest probability of harbor seal haulout occurred 1.5 hours after high tide due to the site not being accessible until higher tide heights. Another study done in the San Juan Islands found that more seals hauled out at high tide at Goose Island, whereas fewer seals hauled out during high tides at Yellow Island. This study supports that the abundance of harbor seals is related to the availability of haulout space during specific tides. I chose to explore harbor seal haulout and tides in the Snohomish River to see if the specific environment displayed any similar correlations. I used data collected from 3 sites up the Snohomish River, with Log Skid being the furthest upriver, followed by North Jetty and Log Boom Jetty on the north end of Jetty Island. My research question has been, does haulout behavior correlate with the tides of the Snohomish River? To investigate this, I used the last 7 years of seal counts from river trips on the Ocean Research College Academy research vessel, excluding 2020 data due to COVID-19 and lack of data collection, and compiled it with NOAA tides data from their website. The first way I tried to visualize this data was with a box plot of the number of harbor seals counted to their behavior. At first, I noticed that it seemed that there were more harbor seals hauled out at ebb tide. However, there is a very large whisker on this box. This suggests that the data is very uncertain and varies. Describing tide by flood and ebb is too broad. A 2-foot tide and a 10-foot tide could both be labeled as flood, so I decided to look more specifically at tide heights. This bar graph groups tide height into bins and has the average number of seals counted on the y-axis. I'd like to draw your attention to the first bar, where the average number of hauled out seals is shown as the highest overall, around 75. However, the arrow bar conveys that this value varies tremendously. I think that this graph would be more beneficial with more data, since this first bar had 3 data points, where the far right bar contains about 10 data points and has a shorter error bar. I still wanted to look at how tide height played a role, so I decided against using averages and graphed seals counted compared to tide height. The graph on the left accounts for all hauled out seal data points, and the one on the right differentiates between swimming and hauled out seals. Both graphs had linear regression lines and produced very low R values, therefore showing no correlation. These are graphs of the hauled out harbor seal numbers to tide height for each of the sites sampled. They also had linear regression done and produced low R values and showed no correlation. To conclude, there is no correlation between harbor seal haulout and tide height in the Snohomish River, which further supports the claim of variable patterns of tide height impact on harbor seal haulout through the Salish Sea. Harbor seals do not follow these similar correlations as other parts of the state, because the areas that they are hauling out on are logs that are able to float on the surface of the water and do not depend on the tides to be accessible for the seals. Further research should explore a larger data set, use seasonal trends, a full tide cycle, potentially use photo ID to get a sense of site fidelity, and explore additional variables to see if anything such as water temperature plays a role. And that is the end of my presentation. Thank you so much for listening. I'd like to thank my collaborators, the Ocean Research College Academy, Everett Community College, and the National Science Foundation. Thank you.